this is mass retardant. We also bring here with us that we should use our first principle again, in which we are into the calculus and we are asked to use our first principle method to solve this problem. Believe me, it's simple. Let's solve it. So the first thing is that let's write solution. This is our solution, right? And we are to use our first principle. We are given that our y is equals to x squared plus what? Plus 3x. Right? This is what we are given. And we are asked to use our first principle. What's our first principle? Our first principle states that our dy dx is equals to the limit, right, as change in x approaches what? 0 of f of x plus change in x minus what? F of x, right? All over change in what? Change in x. That's the first principle. Now, the second one is that, okay, our f of x is something as what? As y, right? So, which our f of x is something as what? X squared plus what? Plus 3x, right? Now, what x do we need? Our what? F of x plus what? Plus change of x. So, in which we have f of x plus what? Change in x is equals to, so anywhere we see x, we put what? F of x plus what? Change in x. So which means we have here will be x plus change in x squared, right? Plus 3 open bracket x plus what? Change in x. Have you seen it? So now, but if you can check this is what? This is squared. So let's expand it, in which this is still the same thing as what? We have x squared plus 2x change in x, right? Plus what? Plus change in x squared, right? Then we expand this plus 3x plus what? 3 change in what? Change in x. Let me partition this, right? So we have that. Now, we are free to substitute everything here into this problem. That's both f of x plus change in x and what? And f of x. Let's substitute to our derivatives. So in which we have our dy all over dx is equals to the limit as what? Change in x approaches 0, right? Is what? Our f of x is this, or the whole of this, right? Which is x squared plus 2x change in x plus what? Change in x squared, right? Plus 3x plus what? 3 change in what? Change in x, right? This is the whole f of x plus change in x. Then minus this guy, which is this. Then we have minus x squared minus 3x, right? All over change in x, which is this guy. Now, if you can see clearly, we can cancel out these guys, right? So when we cancel it out, and this also we still go with this. Have you seen it? So now, which means our dy all over dx is equals to, are you with me? The limit as change in x approaches what? 0, right? What left is here is we have 2x change in x plus change in x squared plus what? Plus 3 change in what? X. All over change in what? Change in x. Have you seen it? We are going. So now, what is common at the numerator is what? Change in x. So let's substitute out. Let's factor it out rather. Sorry. So in which you have our dy dx is equals to the limit as change in x approaches 0 of 2x plus what? Change in x plus 3. All in bracket, change in what? Change in x. All over, change in what? Change in x. So now clearly you can see change in x will go, right? So now what left with us, you have our dy all over dx is equals to, as the limit as what? Change in x approaches 0 of what left? 2x plus what? Change in x plus what? Plus 3. So what this limit means that when change in x is approaching zeros, so here it turns to what? 0. So when it turns to 0, so which means our dy all over dx is equals to 2x. This is 0 already, then plus what? What remains here is what? Is 3. This implies that our dy dx of this function y x squared, y is equals to x squared plus 3x is equals to what? So dy dx of it, that's we are differentiating with respect to x, is the same as what? 2x plus what? Plus 3. I hope you enjoyed the video, this example. And like, comment, share for others to learn as well. Thank you.